what we discussed actually, we discussed that in Stark effect for uh, ground state, sorry, for ground state of hydrogen atom or hydrogen like atoms, ground state Stark effect for hydrogen atom and hydrogen like atoms is zero. There is no Stark effect, so it is absent. And we have proved it quantum mechanically. There was a wave function psi 100 z psi 100 d tau or dr power volume. So it is 100. So this is actually equal to like this psi 100 whole square dr d tau. This was an even function. This was an odd function. Okay, and in parity. So in parity, therefore, whenever we have an integral and in a product of an even function and an odd function, then the integral is equal to 0. When the integral is 0, actually the another way to look into it is that that you have a state psi 100, you have a conjugate of this another state. So that is when you have a state, this is n, l and m. So for any transition to occur, your delta L should be equal to plus minus, and delta L should be equal to 0. Yeah, delta L should be plus minus 1, 0 and plus minus 1, and delta M should be equal to 0. Yeah, this is the selection rule actually, what I remember. So your delta L is equal to plus minus 1 is not satisfied for because L is this is the L. So when this is L, then it implies that L minus L dash is equal to 1, and that means that delta L is equal to, yes, it is equal to plus minus 1, or L is equal to 1 plus minus L dash. So that means L should change actually, but here the L is not changing actually in this case, in this state, psi 100 and psi 100. So there is no change in L, no change in L. So that is why we say that this transition is not possible. And another way of looking classically, if we look classically into it, classically we know that
सर मतलब L to L नहीं हो सकता है.
नहीं, what the L to L हो सकता है transition, but here in this case the L is not changing actually. L to L होना चाहिए, तभी तो transition होगा, L to L change जब होगी. But in this case we are not the L is not changing actually. Yes, so L should change actually, because how you write actually a state, it is sorry N, L and M. Then if we have an H dash perturbation, any perturbation or Z, any operator, and we have a state this. So this state will exist when L is So you should have what I am saying. Wait. In case of this ground state, what is it as ground state? Ground state is S, which is a spherically symmetric state. Okay, so the transition occurs from one state to another state. When it is a spherically state, it is this spherically symmetric state. So when what we know actually is delta L should be equal to plus minus 1. Plus minus 1 means that L will be equal to L dash plus minus 1. Either it go from one L to another L plus minus 1. But here in this case, what we have L equal to L dash. It is 0 in both the cases. In both the cases, it is 0. Here 1 0 0 1 0 0. So there is no change in L actually. So when there is no change in L, so that means the net dipole moment is equal to 0 because of the spherical symmetry. When this net dipole moment is 0, you have no interaction between external field and atom. When there is no dipole moment of the atom in this state. So that is why we say that there is no effect of electric field. So when there is no effect of it, though, there is no Stark effect. There is no Stark effect. The best way to remember is that when you have an integral of parity, odd parity and even parity function, then the integral goes to 0. Just wait, I'm not able to view the message. I will reply later. Yes. Message not able. I'm not able to view the message. So for the first excited state, we have psi. First excited state means that n is 2. When n is 2, L is equal to 0 and 1. M is equal to minus 1, 0, 1 for different states, for these states. So you have fourfold degenerate state, psi 2, 0, 0, psi 2, 1, 0, psi 2, 1, 1, 2, 1, minus 1. These are the four states corresponding to these combinations of N, L, and M. So when you have these four combinations, so there are the possible transition between these four states. And there are 16 such combinations in which the transitions will be possible. Yeah. Okay. So we can write those 16 states, 16 transitions or electric dipole transitions between different states in terms of that determinant, which I have written in psi 200 h dash psi 200. Number first, psi 200. Here we have 200 state. This is 2 1 1 state. This is 210. This is 2 1 minus 1. Okay, so these are the different states which are represented here. So psi 200 h dash psi 211. So it will be like, if you go in this case like this downwards, so it will be 200 211 in downward case, and it will be 210, then it will be here 210 21 minus 1. So along the rows we have 200, first 200 because here is 200, this and this, then it will be 200 211 here. Okay, and in the second case we have 200 h psi 210, and similarly we have here another element that is 20021 minus 1. In this case I can write in simple terms to make it short. It is 200 h dash 200. This is 200 h dash 210 211. Sorry, this is 200 h dash 210. This is 200 h dash 21 minus 1 here. Similarly, this is 211. Here we have 200 in this row. This is actually the first column. These are the columns actually. First column, second column. This is in C1, this is C2, this is C3, this is C4 in columns. Maybe I have kept it in the wrong position, wrong place. I will change the color. So this is here 200 211 210. This is 21 minus 1 in this state. Now you can write, use the dark pen and black. So this is 211 h dash 211. This is 211 h dash 210. This is 211 h dash 21 minus 1. Similarly, this is 210 state now. H dash 200. This is 210 H dash 211. This is 210 H dash 210 210 210 H dash 21 minus 1. So this is 21 minus 1 H dash 200 21 minus 1 H dash 211 21 minus 1 H dash 210 21 minus 1 H dash 21 minus 1. Okay. Now see here. From this determinant you will conclude all things. Now if this is as same as we have the first ground state, like this psi100 h dash psi100. These are the same like that. So these are all diagonal elements. These are the diagonal elements. As in the case of ground state, they were 0, so it is equal to 0. This ground state. Okay, one thing. The another thing is that again we have if you take 2 1, yeah, simply n l m h dash n dash l dash m dash, it is delta ik. Okay, and when you have delta ik, it is equal to 0 for I not equal to k, and it is 1 for I equal to k. Okay, so if you use this concept here, almost all the terms, for example, if you see this, that is m and this n and m. So the transitions 200, m is same. So wherever m is equal to m dash, you will get 0. And wherever m is not equal to m dash, you will get 1. This 0 0 0 0. Wait. This is no, I have kept it reverse. m is equal to m dash, you have 1. When m is not equal to m dash, you have 0. This is the concept in the from this. Yeah, I is equal to k, you have 1, and I is not equal to k, you have 0 from this. So this 0 and 0, this will remain, these will remain, this 0 and minus 1, 0 and 1, this is already cancelled, 0 and 1, 1 and 1, minus 1 and 1. So m change 0 and 0, this is same. So this is 1 0 0 0, this will remain, minus 1 0, 0 minus 1, 1 minus 1, 0 minus 1, minus 1 minus 1. So there are only two states remaining, that is 2 0 0 h dash 2 1 0 and 2 1 0 h dash 2 0 0. Okay, so these states will remain, all other will turn out to be 0. So we have the final states. This is actually 2s state, 2 0 0, 2s state, and side 2 1 0, it is 2p state, because l is 1 here, l is 0 here, so it is p, it is s. So it is plus minus 1 actually, because 1 m equal to 1, then minus 1. That is how this plus minus 1 comes from there. So only two states will remain, and these two states now we have to use. We have to use the wave functions corresponding to these two states. So the diagram is the same as your ground state, this even parity and odd parity function. Like you have psi 1 0 0 h dash psi 1 0 0. What is this? Yes, psi 1 0 0 square z or d tau. So this is an important rule of yes quantum mechanics. तो यहाँ पर क्या होगा, इस odd parity और even parity के साथ, odd parity and even parity, जब आप इन दो functions को आपस में multiple product rule करेंगे, in this case, or even if you take that integral, I will give another option. Write psi 1 0 0 of the hydrogen atom, जो wave function है उसकी. The wave function for psi 1 0 0 is, let me tell you what it is. I will give the value. Psi 1 0 0. Like you have used psi 2 0 0. Similarly, you have psi 1 0 0 there. Table, where is table? I will give the wave function what it is. Table, yes, psi 1 0 0. Psi 1 0 0 is, if you use psi 1 0 0, it is 1 by under root of pi. It is z by a naught actually, 3 by 2. Wait, z by a naught 3 by 2 exponential of minus z into r by a naught. ये wave function है psi 1 0 0 state के लिए. When you take it with z component, which is r cos theta, and integrate over this 0 to infinity, 0 to pi, 0 to 2 pi, it is psi 1 0 0. So you have 1 by under root of pi z by a naught raised power 3 by 2 into exponential of minus z by a naught r into z is r, this is square, remember that this is square, into r cos theta into d tau, and you know that this d tau is equal to,
Yeah.
and d tau, you know that what d tau value has, it is an integral of this. You have to put, actually you have put up the three integrals, so you have to put up the value of d tau here. Yes, it is this integral, so it is easy to solve enough for you. Okay, so solve this integral and find its value, then let me know. If anybody has any problem, I will see it, because we have actually h dash equal to e z. Okay, then this e is constant. You have psi 1 0 0 z psi 1 0 0 to find the energy, total energy for the ground state. When you take h dash 1 0 0 Yes, 100 here. For ground state, this is, I am talking about ground state. This is ground state. Okay. Now that is how it becomes 0 actually. So whenever you solve this same function, even function with an odd, in the integral, it will turn out to be 0. Excited state. So we have 4 fold degeneracy. So there means we have 4 homogeneous equations actually, set of equations. And there are 16 possible transitions, out of which 2 will exist. That is h dash equal to 2 0 0. Here it is z actually. 2 1 0 and 2 1 0 2 0 0. So this 2 0 0 is actually psi 2 0 0. That is a wave function for the first excited state corresponding to n equal to 2. N equal to 2, L equal to 0, M equal to 0. Because we already know that n is equal to 2, L is equal to 0 and 1, M is equal to 0, 1, minus 1. These three values. Okay. So corresponding to these states, so psi 2 0 0, it is equal to actually, this is a ground first excited state. It is E, not E, I will write simply psi first. The wave function is, it is 2s state, because 1s is a ground state, so 2s will be its excited state. So 2s is equal, this 2s, it is equal to 1 over 4 root 2 pi 1 by a naught 3 by 2. It is 2 minus r by a naught into exponential of minus r by 2 a naught. This is 200. This is the first excited state wave function for hydrogenic atoms. And we have psi 1210. This is 2p because L is equal to 1 here. So it is 1 by 4 root 2 pi. Again, it is 1 by a naught 3 by 2. It is
सर
then
Z भी है कि Z हम मान ले रहे हैं
because Z atomic number है. So you can put up Z for hydrogenic atoms, it is 1. For hydrogen, like if we are treating hydrogen, if you can keep the Z, there is no issue. It is an atomic number. So that is a constant value, वो atomic number है. So 2p, it is 1 by 4 root 2 pi, 1 by a naught 3 by 2, r by a naught into exponential of minus r by 2 a naught into cos theta. Okay, so these are the two states which you have to consider while solving the integral actually, because when you take psi 200 z, here it is E psi 210, you are actually integrating it like this. Of r into z into d tau. It is like this, and it is E. I can use now triple integrals, and psi 200 is, now use the value 1 by 4 root 2 pi 1 by a naught 3 by 2 2 minus r by a naught exponential of minus r by 2 a naught into, there is then psi 210, it is 1 by 4 root 2 pi 1 by a naught 3 by 2 r by a naught exponential of minus r by 2 a naught into cos theta into d tau is, it is r square dr sin theta d theta d phi. I will, मैं इसको short यहाँ कैसे करूँ? This 4 root 2 is constant. Okay, here is 4 root 2 pi 1 by a naught 3 by 2 यहाँ पर है, 1 by a naught 3 by 2 यहाँ पर है, r अंदर रहेगा, 1 by a naught बाहर है, ठीक है, this, so it is 3 by 2 3 by 2 2 by 2, so it is 8 by 2, that is 4, so 1 by a naught raised power 4 बाहर आएगा. There is then 1 by 4 root 2 pi 4 root 2 pi, it is 16 into 2 pi, that's 32 pi. So I will write it as, it is E divided by 32 pi 1 by a naught raised power 4. अंदर क्या बचा? अंदर बचा 0 to infinity, let me separate it, r square into 2 minus r by a naught exponential of minus r by a naught to a naught into r by a naught into exponential of minus r by 2a naught फिर से ठीक है। ये टर्म भी आ गई, ये टर्म भी आ गई, ये टर्म भी आ गई और ये टर्म भी आ गई, ये r स्क्वायर भी आया। नाउ देयर इज dr, ठीक है। नाउ इनटू देयर इज इंटीग्रल ऑफ 0 to 2 pi, then there is that is d
0 to pi.
okay, there is z equal to r cos theta, z का वैल्यू आएगा ना ये
Yes, sir.
z,
Yes, sir.
so r अब r क्यूब बनेगा यहाँ पर, r स्क्वायर r 4 है नॉट क्यूब। देखो एक r ये है, ये एक r स्क्वायर यहाँ है और r यहाँ है, तो r 4 आएगा, ठीक। 2 minus r by a naught exponential minus r by 2 a naught, r by a naught exponential minus r by 2 a naught. This and this, it will give you exponential of minus r by a naught only because it is 2 times. So it is 0 to 2 pi. पहले मैं sin theta यहाँ लिखूंगा, sin theta cos square theta, cos theta और cos square, cos theta,
Cos square.
okay, r cos theta and this cos theta is cos square theta d theta, okay. Then there is 0 to pi, sorry it is 0 to pi here,
0 to pi, sir. Phi कर रहा है, where is 0 to 2 pi?
2 pi. Now it is okay.
Yes, sir.
2 pi. Now integral of, so it is equal to e divided by 32 pi 1 by a naught 4. It is r4 and you have 2 minus, sorry I am going in the wrong direction, thoda sa niche. So it is h dash actually, and it is 200210, okay. These are the states. This is 0 to infinity, it is r4, it is 2 minus r by a naught into exponential of minus r by a naught, because minus r by a naught minus r by 2 a naught, so it becomes minus 2 r by 2 a naught, so 2 and 2 will cancel here, it will add as simply, so it will become minus r by a naught. r already आ चुका है, this r is not here because I have already included it, so it is 1 by a naught भी बाहर आ चुका है, यहाँ पर r यहाँ आया है, 1 by a naught यहाँ आया है, and then it is minus r by 2 a naught into dr into integral of sin theta 0 to pi cos square theta d theta into 2 pi. This integral is always 2 pi. This is the polar coordinates and it is e by 32 pi 1 by a naught raised to power 4. It is 0 to infinity. I can do one thing. Let us see what I will do. I will write r by a naught 4 into 2, this into exponential of minus r by a naught. हो गया, यहाँ से ये माइनस ये वाला माइनस ये जो बीच में है, this minus there is r5 by, मैंने a naught raised power 4 अंदर लाया है, so a naught raised power 4 into this a naught, it become a naught 5 into exponential of minus r by a naught, and the integral this whole is dr. Is it okay? This integral you will solve by yourself. I will not solve it. It's 2 by 3 into 2 pi. Now see here, it is r by a naught raised power 4 into 2 यहाँ पर है, let us take 2 outside, 2 यहाँ आएगा, 2 by 3 भी यहाँ आएगा, यहाँ से 2 pi भी यहाँ आएगा, So it is 2 pi e by 32 pi into this 2 into 2 by 3, or 4 by this exponential of minus r into 1 by a naught minus r5 into 1 by a naught raised to power 5. I can write it like this, or simply you can keep it in the bracket. R into 1 by a naught dr. वो सब मैं बाहर ले चुका हूँ. This is already outside. Now pi cancel. It is e 2 2s are 4 2s are 8 divided by 32 into 3 into this is a standard integral. This is again a standard integral. We have integral x raised to power n e raised to power minus ax dx is equal to n factorial divided by a raised to power n plus 1,
Yes.
0 to infinity. Okay, here our a is 1 by a naught. This 1 by a naught. Okay, in the first integral n is equal to 4, so it is 4 factorial, okay,
A naught.
divided by 1 by a naught raised to power 5.
A naught.
Okay,
5.
okay,
So
and 4 factorial 1 by a naught into there is a naught raised to power 4, this not here, it is in the denominator, into 1 by a naught raised to power 4. Is it okay? Just see it. X raised to power n. N is x raised r raised to power 4. This is x raised to power n. There is 1 by a naught raised to power 4. वो यहाँ है. This is it.
yes sir, ठीक है.
Into exponential of minus a n. A is now 1 by a naught here. So that is here 1 by a naught raised to power 4 plus 1 is 5. Okay.
Sir,
Minus this is 5 factorial divided by
1 by
1 by a naught raised to power 6
into 1 by 8 naught 5.
a naught 5. This is it. Yeah, like so it is e into 8 by 3 divided by 32. Pi cancel हो चुका है. There, let me take it straight. I am going. So it is equal to e divided by 32 into 8 by 3. यहाँ बचा है 4 factorial divided by a naught raised to power 4 into a naught raised to power 5, because this will go in the numerator, minus 5 factorial into a naught raised to power 6 divided by a naught raised to power 5. So a naught 4 और यहाँ 5 और ये 4 कैंसिल, 6 और ये 5 कैंसिल, वहां बचेगा 1 यहाँ से और 1 यहाँ से, वो मैं कॉमन निकाल लूंगा.
E epsilon by 12.
Okay, यहाँ 4 into 3 into 2 minus 5 into 4 into 3 into 2. ठीक है. So it is e divided by 32 into 8 by 3 into 4 into 3 into 2 में बाहर निकालूंगा दोनों जगह से. यहाँ a naught भी है. So this is 1, this is 1 minus 2. 5 sorry.
5 sir.
5.
ठीक है.
A naught. Yes.
So it is a naught e divided by, now 4 8s are 32. This is now, this is 3 and 3 cancel. Okay,
3 4 and 4. Yes sir.
I have done one thing wrong actually. What I would remember, let me show you कहाँ पर गलती हुई है. Wait, ये 2, because this 2 is only multiplied to this term, not to this. If you see it clearly,
2 is 4 factorial.
यहाँ पर ये जो 2 है ना, this 2, this is not multiplied with to each term. So this we have missed actually. So here we have 2 here. Is it okay? ये वाला 2, ये these two, this, here it is, this. So this I writing here, so it is 2 into, so there is 2 into
2 into 4 factorial.
2 into 2. Is it okay? किसी को कुछ प्रॉब्लम तो नहीं है इसमें? If anybody has problem, please let me know. In that case, आपके पास notes है, मैंने ये step by step वहाँ किया हुआ है. So it is 2 minus, so it is AE, this 3 and 3 cancel. 30, this 8, 4 2s are 4, okay, wait. Yes. Let me write it again.
Sir.
Yeah, I will write it again, no issue. So it is E divided by 32 into 8 by 3 A naught. This is A naught into 4 into 3 into 2. Common निकालेंगे. This is 2 minus 5. Okay. 3 or 3 cancel. 4 2s are 8. 8 4s are 32. Some issue is there. 8 4 8s are, wait. Yes, कहीं पर कुछ प्रॉब्लम हो रही है. This is the we have some issue here. यहाँ से देख लो. 2 by 3 into 30. 2 by 3 into 2. यहाँ गलती हुई है. ये 2 हमने बाहर निकाला है यहाँ पर. So I can write it here. So it is E. Keep a visual on it. 2 by 3. आप लोग भी नहीं देखते हो ना. That is problem. आप अगर देख लेते इतना problem नहीं होता. So it is 4 factorial into 2 divided by यहाँ A naught raised power 5 divided by A naught raised power 4 minus 5 factorial into A naught raised power 6 divided by A naught raised power 5. Pi or pi cancel, so it is E divided by 32 into 4 by 3 into 4 into 3 into 2 so h dash is equal to E divided by 32 into 2 by 3 into 2 into 4 into 3 into 2. Here we have A naught. Then we are left with 2 minus there is 5. Okay, so it is A naught E divided by 32. This is 3 and 3 cancel out. This is 4 into 4 into 2. 4 4s are 16. 16 2s are 32. This whole will cancel out. Here is minus 3. So it is minus 3 A naught E. This is H dash. This is the shift actually, that perturbation, because of that perturbation. And since it is a quadratic equation, we have two states. So there is a quadratic equation. The shift will be symmetrically plus minus 3 A naught E. This is what I have sent you in detail. And if you plot this, if this is psi 200, psi 210. So this difference is 3AE. Wait. A naught. This gap. So this is m equal to 0. This is m equal to plus 1 state. M equal to minus 1 state. Okay, so I have sent you through this, and check those notes again if anybody has not seen them. And this finishes your second unit.